37 is a little different because it's a brother-sister pair. So first off, since it's an inverse, those quadrant stipulations still apply, and they're super important. So since I'm looking for inverse cotangent, I'm in quadrants 1 or 2. Since this is positive, I'm in quadrant 1. Now that I know I'm in quadrant 1, I'm going to switch it to the brother-sister pair, so inverse tangent, which means I have to flip this. So technically this is over 1, so it would be 1 over root 3. And I'm not going to simplify this because I'm looking in quadrant 1 where tangent, my toe, is 1 over root 3. So you would look at your triangles. I just drew this one already. And if I want an opposite of 1 and an adjacent of root 3, I'm working from pi over 6. So pi over 6 is my answer. But I do want to point out that I'm still in the same quadrant that I originally found. So what a lot of people will do, which is wrong, is they'll try to switch the quadrants because you switched it to inverse tangent, but you always stay with your original quadrant. So since I'm solving for inverse cotangent, I'm keeping this quadrant. Don't redo the quadrants just because you change it to an inverse tangent. I'm only changing it so I can actually find the answer. So again, I found the quadrant, I switched it to the brother-sister pair, which means I flipped this, and then I didn't simplify it because I wanted to find it in my triangle. And tangent, opposite 1, adjacent root 3 happens at the pi over 6. All your answers have to be in radians, so pi over 6 is the answer. 50, another brother-sister pair. This one was with a calculator though. So first off, since it's negative, I'm going to be in quadrant 2. Now, what that means for you is if you're in quadrant 2, this is pi, this is half a pi. So you know pi is 3.14, half a pi would be 1.57. I need to be between 1.57 and 3.14 for my answer. So when I go ahead and flip the inverse cotangent to inverse tangent so that I can type it in my calculator, I flip that to -2. When I type that in my calculator, make sure you're in radians, and you get about -1.107. Now, if it's a -1.107, if this is 0, negative would graph down. So -1.107 is actually in quadrant 4. You bump it up by making it positive, 1.107, and then you bump it over by doing the leftovers of pi. So you would do pi, 3.14, minus that 1.107, and you get about 2.03. And 2.03 falls between the 3.14 and the 1.57, so it works. So again, I did the inverse tangent of a -2, got the -1.107. That's in quad 4. Bump it up by making it positive, and then you bump it over by doing the leftovers of pi. So you subtract it from pi. 52 is very similar. Again, it's inverse cotangent, so I'm limited to quadrants 1 or 2. Since it's negative, I'm in quadrant 2. So again, that means I'm between pi, which is 3.14, and the half a pi. If I take 3.14 and cut it in half, 1.57. So that's where I have to be. When I type that into my calculator, I can type it in as inverse tangent, but this is over 1. This negative, if you think of it as a fraction, it'd be over 1. So you flip it, 1 over -8.1. When I type that into my calculator, I get -0.1229. And I don't remember, honestly, how many decimal places they told you to use, so just do whatever the book says. But -0.1229, if this is 0, negative would graph down, so that would actually fall here. And you can see I'm not in the correct quadrant. You can't jump diagonally. You have to go to the next closest quadrant and never go to quadrant 3 ever. So we're going to go up by making it positive, and then you're going to go over by doing the leftovers of pi. So if I do 3.14 minus that 0.1229, I get about 3.02. Actually, let me type that in my calculator quick. I don't know if that's right. 3.14 minus 0.1229. Yeah, it would round to 3.02. Let's just leave it like that. And 3.02 falls between the 1.57 and the 3.14, so it fits where it belongs, so that is your final answer.